Who's inside that sign? Who's inside? I don't know yet. I gotta take the derivative of sine. Right? Yeah. Great question. Treat t and x as both functions. Just like when we're doing that like f of x times g of x. Treat them as functions. Like treat it as like a y and an x. So you would have to product rule. It's not a number. You know what I'm saying? It's a variable, meaning something that's changing. You know what I'm saying?
So if it's just a number, then you don't.
Exactly. If it's a number, it's a constant. And you could do product rule too, but then when you take the derivative of the constant, it would equal 0. So that part is negated. You know what I'm saying? You could do product rule on 5x. You know what I'm saying? That'd be 5 times the derivative of x, which is 1, plus the derivative of 5, which is 0 times x. That's gone. Does that make sense?
Yeah, but I didn't know where to go.
So this is a product rule. Excellent for recognizing it. X times t is a product rule. So when you take the derivative of this, before you do product rule, do your product rule. Time. Derivative of the first times the second plus the first times derivative of the second. Okay, now I'm ready to take some derivatives. Okay, so this is all good. There's no work here. I'm just going to bring it down. Cos of xt times, what's the derivative of x in terms of x? 1. What's the derivative of t in terms of x? T prime, or dt dx. What's the derivative of t in terms of x? The derivative of t in terms of x. T prime. The derivative of t in terms of x is dt dx. So how do we solve for dt dx or t prime? How do you solve this? We're right. But then you're going to have a, you know what I'm saying? Like, there's going to be a t prime with a denominator. I always divide last. Yes. Multiply everything by cos xt. Distribute it. That would be t cos xt plus xt prime cos xt equals t prime. Now how do you solve for t prime?
Bring t prime to one side.
Get all your t primes on one side, anything without a t prime to the other side, factor out and divide. Does that make sense, you guys? So I want to keep this here. Here's a t prime thing. Here's a t prime thing. I need both of those on the left. Stat. Doctor, I need a t prime on the left. Stat. xt prime cos xt minus t prime equals negative t cos xt. Yes? These over here. Get out of here with that thing. Factor out a t prime. X cos xt minus 1 equals negative t cos xt. And then divide. negative t cos xt all over x cos xt minus 1. Can I split up that denominator into the two equal pieces? You guys, this denominator, the negative t cos xt over x cos xt minus 1, can I split up that denominator? Because I think we can get some canceling, right? No, you can't split up denominators. Don't forget that, okay? Alright, you guys, everyone stop what you're doing for a second. Everyone stop and look up here. Is everyone fine with this problem? Ask your questions, everyone up here. Are there any questions on this problem? We just solved for, we d dx both sides, and we solved for the change in t over change in x. We solved for t prime. Yes? So, from which step? Here? So from here, I got anything with a t prime on the left. Anything without a t prime on the right. And as soon as you do that, this thing, this is all multiplied together. X times t prime times cos xt. That has a t prime in it. This is a t prime in it. So you can factor it out. Like it's the same as this, Eric. You got x squared plus 5x. This has a, you can undistribute it. You can factor out an x. X parentheses, x plus 5. You can undistribute it. Does that make sense? So once you get just t's on one side, you can factor out the t prime. You just have x cos xt minus, so this times this would be this times this would be this. Does that make sense? But as soon as you have it like t prime times some junk, then divide both sides by that junk, and then now you magically have t prime by itself. Does that make sense? Good question. Any other questions? Solve that then. I want you to find the change in x in terms of t. I want you to d dt both sides of the equation. Does this change? Well, I haven't done anything yet, but you're right about that. But does anything change here as far as the setup? Prime being on the outside of the parentheses meaning I haven't taken that derivative yet. Is this the same?
Yeah. It's the same like they solved it.
Is this the same?
Yeah.
The only difference, you're exactly right, I mean, is when you start taking the derivatives. This is where it starts changing right here. The first time d dt, finding the rate of change in terms of t, or if I d dt both sides of the equation, the first change would start happening here. Talk to the group through this one.